Hello everyone. We are going to solve a system of equation using elimination. So in the past we've solved these systems by graphing or using substitution. We also know Cramer's rule from our matrix unit, and today we're going to learn elimination. So our goal with elimination is to eliminate one of our variables by adding our two equations together, and then we'll use our solution to solve for our second variable. So our goal is to solve this system right here, these two equations. However, it's really important that we write our equations in standard form if they are not given to us that way. So standard form, remember, is ax plus by equals c. So I went ahead and rewrote these so that my x and y were on the left side of my equation. And now our goal is to add our two equations together to cancel off a variable. Well, we get really lucky right here because notice our y's, if I add those together, -2 plus 2, that cancels off. So our goal is to get opposite signs and the same coefficient so that our variables cancel. So I went ahead and added our two equations. So we get a 4x. Like I said, these y's cancel. And then 15 plus -11 gives us 4. So now I have an equation that I know how to solve. So I just divide by 4 and get x equals 1. So we use x equals 1 and substitute it back into one of our original equations to get our y. So I substituted it into the bottom equation, 1 plus 2y equals -11. Subtract 1, divide by 2, we get y equals -6. And we always want to make sure we write our solution as an ordered pair, so 1, -6. Here's another example. We're not as lucky with this one because one of our variables doesn't just automatically cancel. So our goal is to make them so that they cancel. So we can multiply one or both of our equations in order to make that happen. Now, like I said, we really want opposite signs. So our y's don't have opposite signs, but our x's do. So I'm going to go ahead and eliminate my x's. Well, in order to do that, I need to find my least common multiple of 2 and 3. Well, my least common multiple would be 6. So I need to multiply my top equation by 3 and my bottom equation by 2. So I do that here. Once we multiply, make sure you multiply all the way across to the constant as well. But once you multiply, you get these two equations. And now I'm going to add those together. So my x's will cancel. I'll be left with a 19y equals -190. Again, this is a one-step equation that we can solve really easily. We get y equals -10. So we plug this y equals -10 back into one of our beginning equations. So I plugged it in the top equation, solve there to get x equals 8. So our solution is 8, -10. One last example. Here is another type of equation or scenario, I guess. Here we have a coefficient of 1 in front of our x, and sometimes that is really nice because it ends up in we only have to multiply one equation. So if I chose to cancel off my x's, I would only have to multiply this bottom equation by -9. However, if I chose to cancel my y's, I could do that as well. I just have to multiply this bottom equation by 4. So I went ahead and canceled off our x's. So like I said, multiply that bottom equation by -9 because we want those coefficients to be the same number with opposite signs. So once we multiply through to the bottom equation, we have -9x plus 18y equals -45. And now I can add my two equations to get 26y equals -52. Solve that to get -2 for our y value. Again, plug y equals -2 into one of your top equations and solve. So I got x equals 1 when I plugged -2 into the bottom equation. So our solution is 1, -2. I did make a note here. Remember, this isn't the only way we could have solved. We could have easily multiplied this bottom equation by 4, and then we would have canceled our y's. We would have gotten the exact same equation or exact same answer. So you can do it however you choose.